Okay, we're going to start off by deriving the formulas for the law of cosine. And we are first going to look at the triangle, or the right triangle, that's on the left side of the diagram. I'm going to highlight it in blue so you know where we are starting. First thing I want to do with this right triangle is Pythagorean theorem. So Pythagorean theorem states a squared plus b squared equals c squared. So for one leg, the bottom leg is a minus x. So that's going to be a minus x squared plus the other leg is 8, so that would be 8 squared, equals hypotenuse squared, which would be c squared. Now we are going to square that binomial. Some of you missed this on our logs test. When you square a binomial, here's the shortcut. If I have a binomial that is squared, square the first one. So if I square the first term, that would be a squared. Multiply them and double it. So if I multiply a and b, that gives me ab. Double it, that gives me 2ab. And then the b needs to be squared. So using that shortcut, if I square the first term, that gives me a squared. Multiply them and double it, that gives me minus 2ax. And square the last one, and that gives me plus x squared plus h squared equals c squared. Now the next thing I want to do is replace the x squared plus h squared with an expression that is equivalent. And my advice to you is look over here on the right side. So I want to replace x squared plus h squared with something equivalent. Notice x and h are the two legs. So I'm doing x squared plus h squared, and what should that equal? Yeah, c squared. That's Pythagorean theorem. A squared plus b squared equals c squared. So x squared plus h squared can be replaced with what? b squared. b squared. So this would be a squared minus 2ax plus b squared equals c squared. So Pythagorean theorem, x squared plus h squared equals b squared. So we replace the x squared plus h squared with b squared. Next thing I want to do is the commutative property. So we're going to switch the order of these terms, and I can do that because addition is commutative. So I'm going to switch this as a squared plus b squared minus 2ax equals c squared. Now we're almost there. Now we're going to look at this red triangle. So let me switch to red. And looking at the red triangle, I want to find the cosine of angle C. How do you find cosine?
Adjacent over hypotenuse.
Yeah, SOHCAHTOA. So for cosine, it's adjacent over hypotenuse. So what side is adjacent to angle C? X, and the hypotenuse is B. We're going to solve that equation for x. So the opposite of divide by b would be multiply both sides by b. So that would be b times the cosine of angle C is equal to x. So over here, I'm going to replace the x with what we just solved for. We said x is equal to what? B cosine of C. Get back to my equation. This will be a squared plus b squared minus 2a, and I'm going to replace the x with what we solved for over here, which is b cosine of C. And that equals c squared. And that is called the law of sine. Not the law of sine. That is called the law of cosine. And you do need to memorize it. It does look pretty long, and there are 3 versions of it.
Uh-huh.
But I will show you some little tricks to help you remember and quickly come up with it yourself. Okay, so that's not the most common way we see it. The most common way that the law of cosines is written is just c squared equals a squared plus b squared minus 2ab cosine of angle C. And let me tell you kind of where some of these numbers come from, or variables come from, and then we'll derive the other 2 formulas. Okay, so what you need to notice is that whatever side is by itself, that angle needs to match. So if this is cosine of angle C, then it's going to be a c squared out front. Now, we're talking about a triangle ABC. So if I'm using C, what are the other 2 sides of the triangle? A and B. So it's going to be c squared equals the other 2 sides squared, which is a squared plus b squared, minus 2, and then we'll use the AB again, and then there's going to be the cosine of the third one, which is C. Now the other 2 versions are going to be very similar to that. So if I use the formula with the a squared, then this needs to be cosine of angle A. And if I'm using side A, what are the other 2 sides? B and C, so this would be b squared plus c squared minus 2 bc times the cosine of angle A. So that's the second version. And there's one final version, which would be the b squared. If I'm using b squared, then at the very end, this needs to be cosine of angle B. Those need to match. Now if I'm using B, what are the other 2 legs? A and C, so this would be a squared plus c squared minus 2 AC times the cosine of angle B. So those are the 3 versions of the law of cosine. Now really you don't have to memorize all 3, you just need to know one of them and generate the pattern so you can find the other 2 quickly. So you just have to memorize one version and you should be able to come up with the other 2 if you know the pattern. Okay, so we have several examples with that. So let's take a look at example 1. Oh, before we get to the examples, I forgot. We have this little important note that tells us that, first of all, bullet number 1 tells us that the law of cosines and the law of sines can be used to solve non-right triangles. So that means you can use law of sines and cosines if you do not have a 90-degree angle in your triangle. Second bullet tells us that the law of sines cannot distinguish between acute and obtuse angles. And we saw that yesterday when we had the 2 cases. We had case 1 with the acute angle, case 2 with the obtuse angle. And it says, and it tells us the reason why the law of sines cannot distinguish between the acute and obtuse case is because in quadrants 1 and 2, both angles are going to be positive as far as the ratio of sines. And we'll learn about this when we get to the unit circle. But we're talking about the 2 cases. So case 1 could be if your angle is acute. What does acute mean? Less than 90 degrees. So if it's less than 90 degrees, that means it terminates in quadrant 1. But if I have the obtuse case, what does obtuse mean? Greater than 90 degrees. So if that angle is greater than 90 degrees, then it's going to terminate in quadrant 2. Now when we talk about the law of sines, not the law of sines, when we talk about the unit circle in unit 5, we will learn that in quadrant 1, sine is positive, and in quadrant 2, sine is also positive. So if you get a positive ratio for sine, I can't tell if it's going to be an acute angle in quadrant 1 or if it's going to be an acute angle an obtuse angle in quadrant 2. Because in both quadrants, the ratio for sine is going to be positive, and we'll learn that later. So that's the reason why the law of sines cannot distinguish between the acute case and the obtuse case. But luckily for us, We won't have the two cases today because the law of cosines can distinguish the difference between the two. Because we'll learn with the unit circle that in quadrant 1, cosine is positive, and in quadrant 2, cosine is negative. So if I get a positive ratio for cosine, then I automatically know it's the acute angle because in quadrant 1, cosine is positive. But if I got a negative cosine value, then I would automatically know that it's the obtuse case. So that is just the distinction I need to make here. The whole importance of this is we won't have two cases today. And the reason why is because the law of cosine can distinguish the difference between the acute and obtuse angles. So we don't have to do the two cases today. And here's the important bullet at the bottom. It says that when solving for the angle, if there is any possibility that the angle you are solving for is obtuse, do not use the law of sine. So I would put a star by that or something. But if the angle you are solving for is obtuse, what does obtuse mean? Yeah, so if you're trying to solve for an angle, and it could be more than 90 degrees, then this note tells us do not use the law of sine. So if it can be obtuse, do not use the law of sine because it could give you a wrong solution. So if it is obtuse, you don't use the law of sine, you have to use law of cosine. So that is the important thing for today. If it's possible for the angle you are solving for to be obtuse, so if it's possible that the angle could be more than 90 degrees, then you have to use the law of cosine. If it's acute, you can just do law of sines, it's going to be faster. Okay, so if that angle is obtuse, or if it's possible that your angle is obtuse, you have to use the law of cosine. Okay, solving these triangles. Remember, when you solve triangles, you need all three angles, all three sides. And I'm going to draw myself a quick diagram. Side A is 9, side B is 10, side C is 13. And fill that in on our answer blank. Okay, we need to solve for angle A, angle B, and angle C. I want to start with the largest angle. So out of those three sides, which one is the longest side? C. So that longest side is going to be paired with the largest angle. So let's do C first. So if I want to solve for C, I need to use the version that has the C squared. So our formula is C squared equals, if I'm using C, what are the other two sides? A and B. So this would be A squared plus B squared minus 2 AB cosine of angle C. So that's the formula that you need to memorize. Now fill in what we know. What do we put for side C?
13.
What's 13 squared?
169.
So 169 equals, what is A?
9.
What is 9 squared?
81.
81. Plus, what is B?
100.
10. So 10 squared would be 100 minus 2 times A is 9 times B is 10, and then we'll have cosine of angle C. Now we need to get the cosine of angle C by itself. So we need to do a little bit of cleanup. So bring down the 169 and the equal sign. Combine your like terms. What is 81 plus 100? 181. Multiply these three with negative 2 times 9. With negative 18 times 10? Negative 180. cosine of angle C. What's the next step to solve for cosine of C? Subtract 181 to both sides. What is 169 minus 181?
Negative 12.
Negative 12 equals negative 180 cosine of angle C. Divide both sides by negative 180. So that gives us cosine of angle C is equal to a negative divided by a negative becomes positive. Now 12 over 180 does simplify, but it's ready for the calculator anyway. So have the calculator do it for you. So if this is an arc cosine value, how do I need to remember to put this in the calculator?
Cosine inverse.
Cosine inverse. So we need to do cosine inverse.
86.
Was it 12 over 180? So do inverse cosine of 12 over 180. And it's set to round to the nearest whole degree, right?
Yes. 86.
Yeah, so the nearest degree, that would be 86 degrees. So angle C is approximately 86 degrees. So let me fill that in up here.
So when I said, do we just use multiplying to take it up?
Okay, from here, when I solve for angle B and angle A, I have to decide, could it be obtuse? So if this is the largest side and this is the largest angle, what do I know about angles A and B? They have to be smaller than what?
86.
86. So is it possible for B to be obtuse? No. So that means I can use the law of sine. So if it could be obtuse, you have to use the law of cosine. But we can see it's not going to be obtuse, so we can use the law of sine. Yes.
I like to not use rounded numbers.
Huh? Here we can't avoid using rounded answers. So here we will have to use rounded answers. If you can't avoid it, then yes. Okay, so now let's do law of sine. So this would be sine of 86 degrees over side C is 13 is equal to, let's do B first, so that would be sine of angle B over 10. Cross multiply, so this would be 13 times the sine of angle B is equal to 10 times the sine of 86 degrees. Divide both sides by 13. So that gives us sine of angle B is equal to 10 times the sine of 86 degrees divided by 13. That is an arc sine value, so what do I have to remember in the calculator? Do inverse sine of that fraction, and we're rounding to the nearest degree. 50 degrees, we agree?
Yes.
Okay, so angle B is 50 degrees.
So can we just find A from subtracting?
Yeah, subtract from 180, so these add up to 136, so what's 180 minus 136?
144. Or 44, my bad. Sorry.
44.
180.
So 44 degrees, so there's all three angles, all three sides. So, here, when we first started, we had A, B, and C. Why did I go with C first?
Because the
That was the biggest, because then after that, I would know if the other angle would be obtuse or acute. So since it was not going to be obtuse, we could use law of sine. Okay, next one, number 2. I'm going to draw myself a diagram. And this time, if you're using degrees and minutes, your answer also needs to be degrees and minutes. Fill in what they gave us. Do I know which one's going to be the longest side? I can't tell from this. So, now I have to decide, am I going to use a squared, b squared, or c squared? Which form of the law of cosines am I going to use? So look and see, what angle did they give you? Angle A. So if they gave you angle A, do we use the formula with a squared, b squared, or c squared? A squared. So the formula for a squared is going to be a squared equals, if I'm using a, the other two sides are c squared plus b squared minus 2 BC cosine of angle A. Fill in what we know. A, we don't know A, so we're going to leave it a squared equals. B is 12, so 12 squared is 144 plus C is 14, so 14 squared is 196 minus 2 times 12 times 14 cosine of 39 degrees, 24 minutes. Now this is calculator work. To solve for A, what is the inverse of squaring? Square rooting. So to solve for A, we need to take the square root of that entire equation. Now when we get our answer, the sides, we're going to round to the nearest tenth. So don't do all the prep work, just put it straight in the calculator. So control x squared, was it 144?
Yes,
Plus 196 minus 2 times 12 times 14 times the cosine. Oh, I'm not even under the radical. Then I need cosine. And what was our angle? Oh,
39 degrees and 24 minutes.
let me do my shortcut for 39 degrees. And then we have 24 minutes.
Lawson,
Yes,
how do you convert it from, like, minutes to seconds?
we'll do the converting here in just a moment when we get there. Okay, so to the nearest tenth, what would that be? 9. Okay, so A is approximately 9. Now I can tell which one is going to be the largest angle. Angle C. So let's do angle C. So if I want to do angle C, which form of law of cosines would I have to use? Now, why am I using law of cosines?
Don't know the
Yeah, I do not know. Is it possible that angle C could be obtuse? Yes. So if it's possible that the angle you're solving for could be obtuse, you have to use law of cosines. So now, if we're looking for angle C, we need to use the equation with C squared. So C squared equals, the other two would be A squared plus B squared minus 2AB cosine of angle C. Now I can see the formula above, and I see that C squared we put 196. A, we just solved for A, we said A was 9, so 9 squared would be 81 plus, up here I can see B squared was 144 minus 2 times 9 times 12, and we are solving for cosine of angle C. Now we'll do a little bit of cleanup. Combine our like terms, which is 81 plus 144. 225. Multiply these three. What's negative 18 times 12? Negative 216. Cosine of angle C. To solve for cosine C, what do we do next? Subtract the 225 to both sides. What is 196 minus 225?
Negative 29.
Negative 29 equals negative 216. Cosine of angle C. Divide both sides by negative 216. So that gives us cosine of angle C is equal to a negative divided by a negative becomes positive. This is an arc cosine value. To make sure you do inverse cosine in the calculator. When you do inverse cosine, was it 29
Over 216.
over 216? Now, for our answer, if that first angle they gave us was degrees and minutes, then our answer needs to be converted to degrees and minutes. So once you get this 82.284, we need to convert that to degrees and minutes. So you need to go to that book, and under tab 2, we're in the angle menu, and under the angle menu, we want convert to degrees, minutes, seconds. So for our rounding rule, if it's 30 or more, it rounds up. So if it's a 3, is it going to round up?
No.
No. So this is 82 degrees, 17 minutes. So 82 degrees, 17 minutes. And to find the third angle, just subtract from 180 degrees. So you need to do 180 degrees minus 39 degrees, 24 minutes, minus 82 degrees, 17 minutes, and what did you get?
58. Or, 58 degrees, 19 minutes.
58 degrees, 19 minutes? We agree?
Yes.
Okay, so the law of cosines, we just have the one case. Next one, number 3. First thing we're going to do is make my diagram. Angle B is 35 degrees. Side A is 5. Side C is 6. Can I tell which side is going to be the longest from the information they gave me? No, so that's not helpful. But if they gave you an angle, then you'll know where to start. So if they gave us angle B, do I use the formula for A squared, B squared, or C squared?
B squared.
B squared. So B squared equals, the other two would be A squared plus C squared minus 2AC cosine of angle B. So this is not hard, it's just to fill in what we know. We're solving for B, so leave the B squared. For A, 5 squared would be 25. For C, that would be 6 squared is 36. Minus 2 times 5 times 6 times cosine of 35 degrees. To solve for B, the inverse of squaring would be square root it. And just type all of that in. Round to the nearest tenth. Do we have an answer? 3.4. We agree? Okay, so angle C is going to be our biggest one. Is it possible for angle C to be obtuse? Yeah, it's possible. So if it's possible, can I use law of sine? No, I have to use law of cosine. So law of cosines again, but this time if I'm going for angle C, I need to use the formula with
C squared.
C squared equals A squared plus B squared minus 2AB cosine of angle C. Fill in what we know. I'm going to kind of use this formula. So we just said C squared was 36. We just said A squared was 25. Plus, we just solved for B. What is B? 3.4. What is 3.4 squared? 11.56 minus 2 times 5 times 3.4 cosine of angle C. Do some simplifying. Combine your like terms, so it's 25 plus 11.56. 36.56. Multiply these three, so what's negative 10 times 3.4? Negative 34. Cosine of angle C. Solving for cosine of C, what do we do next? Subtract 36.56. So 36 minus 36.56 would be negative 0.56 equals negative 34. Cosine of angle C. What's next? Divide both sides by negative 34. And this is an arc cosine value, so make sure you do cosine inverse of 0.56. Divide by 34. And how are we rounding this one for the degree?
To a whole?
Nearest whole degree. And what would that be?
89.
89 degrees. So C is approximately 89 degrees. And 89 plus 35 would be what?
124.
And what's 180 minus 124? 56 degrees. Okay, two more. Okay, number 4, it says that a parallelogram has sides of 55 centimeters and 71 centimeters. Find the length of each diagonal to the nearest tenth if the largest angle measures 106 degrees. I'm going to draw a parallelogram. And the sides are 55 and 71. And they tell us that the largest angle is 106. So in the parallelogram, we have an obtuse angle and we have an acute angle. So if it's 106 degrees, that's the obtuse angle. And they want us to find the diagonal. So here is, I'll call this diagonal 1. And let me draw a new parallelogram, because we also have to find the second diagonal. So again, we have 55, 55, 71, 71. And parallelogram, the opposite sides are parallel. So if these are parallel lines, and this is my transversal, then I know that these same side interior angles add up to what? 180. So subtract 106 from 180, and what would the acute angle have to be? 74 degrees. And the second diagonal would be this one. Oops, I was trying to change it to red and it didn't change. And I'll call that one D2 for diagonal 2. And let me call this angle A, angle B, angle C. And let me call this angle A, angle B, angle C. Okay, so looking at my first parallelogram, if I want to solve for diagonal 1 and we have angle B, do I use the formula with a squared, b squared, or c squared?
Wait.
B squared.
B squared. So this would be b squared equals a squared plus c squared minus 2ac cosine of angle B. So B, the side opposite of B is the diagonal. So this would be d1 squared, so diagonal 1 squared, is equal to, what is side A? 71 squared, plus what is side C? 55 squared, minus 2, times 71, times 55, times cosine of angle B is 106 degrees. To solve for diagonal 1, what is the inverse of squaring? Square root it. So square root all of that, and we will round to the nearest tenth. And once you get that one, I want you to solve for diagonal 2. Okay, so for diagonal 1, what did you get for diagonal 1 to the nearest tenth?
101.1.
Yes, I agree, 101.1 centimeters. Okay, now we need to do the same process for the second one. And now this is angle A. So if I know angle A, which formula do I use? A squared, B squared, or C squared? A squared. So this would be A squared equals B squared plus C squared minus 2BC cosine of angle A. Okay, I want you to find that second diagonal.
76.9.
So we are solving for D2, so that should be D2 squared equals B is 71 squared plus C is 55 squared minus 2 times 71 times 55 times the cosine of angle A, which is 74 degrees. The inverse of squaring would be square root it. And if you didn't want to retype all of that, you could just arrow up 2 times, copy it, and change the 106 to 74 degrees. And the answer was 76.9 centimeters. And the last one. We have side A is 6, B is 12, C is 15. Okay, so we have A, B, C. Side A is 6, side B is 12, side C is 15. And it says find the length of the median to the longest side. What is median? What does the median do? Yeah, it cuts it in the middle. So we need to find the longest side, and which one is the longest side? Yeah. It doesn't look like it according to my diagram, but side C is actually the longest one. So the median is going to cut that in half. So the midpoint, what is halfway of 15? Or what's half of 15?
7.5.
So this side would be 7.5. This side is 7.5. And the median is going to be coming from angle C. And we want to find the length of that median, so I'm going to call that x. In order to solve for x, we really need to know an angle. But were we given any angles here? No. So in order to solve for an angle, we need to use the big triangle. Right now we have 3 triangles. We're going to be looking at the big triangle first. And looking at that big triangle, I want to know, what is angle B? So if I want to know angle B, do I use the formula with a squared, b squared, or c squared? B squared. So this would be b squared equals a squared plus c squared minus 2ac cosine of angle B. What do I put for B? Looking at the big triangle, B is 12, so 12 squared is 144 equals, what is A? 6 squared? 36. Plus, using the big triangle, side C is 15, so 15 squared is 225 minus 2 times 6 times 15 times the cosine of angle B. Do some cleanup. What's 36 plus 225? 261. Multiply these 3 with negative 12 times 15. Negative 180. Cosine of angle B. Solving for cosine of B, what do we do next? Subtract 261 to both sides. Negative 117 equals negative 180 cosine of angle B. Divide both sides by negative 180. And negative divided by negative becomes positive. This is arc cosine, so make sure you do cosine inverse. And what is angle B to the nearest degree?
49.45.
49.45.
That'll be 5. I mean 50. Yeah.
49 degrees.
49.
49.
49. Okay, so now we know that the top angle up here, this is 49 degrees. Now I'm going to be looking at the top triangle. And looking at the top triangle, now that we know an angle, now we can find the length of that median. So now we can find side x. So we're going to do the same formula again because it's still angle B that we have. So we're still going to do b squared equals a squared plus c squared minus 2ac cosine of angle B. But now we're doing it for the small triangle at the top. So for the small triangle at the top, we're looking for the length B, so I called it x. So it's going to be x squared equals, and let me add an a right here at the midpoint. And what is side A? 6, so that would be 6 squared. Plus, what is side C on that small triangle? 7.5 squared minus 2 times 6 times 7.5 times the cosine of angle B, and we said that was 49 degrees. The inverse of squaring would be square root it. And the length of that median, we need to round to the nearest tenth, and what would that be to the nearest tenth? 5.8. We agree? Yeah? Okay, 5.8. Okay, on your homework, all work on notebook paper.